Here on Earth, an object's movement is governed by Newton's laws of motion. Whether we realize it or not, demonstrations of these laws can be observed within everyday life. Physics, man.
Newton's first law explains that an object at rest will remain at rest, or an object in motion will remain in motion at constant velocity unless acted upon by a net external force. Let's look at an example of Newton's first law.
Once the ball was kicked, an object at rest was put into motion by my foot, an external force. After the ball was in motion, it was stopped by James, another external force. Now, let's see what another example of Newton's first law is.
Ah, my ankle.
Steph Curry with the shot.
This is an example of Newton's first law because the motion of the ball was stopped by the opposing force of the backboard. If it wasn't for Newton's first law, the ball would have continued in its path through the backboard. Now let's look at Newton's second law. The second law states that the acceleration of an object is directly proportional to the net force acting on the object and inversely proportional to the object's mass.
This can also be represented by the equation, sum of all forces equals mass times acceleration.
Jesus, take the wheel, take it from my hands, 'cause I can't do this on my own. Oh, halfway there. Oh, give me a prayer. Take my hand, well, baby, I swear. Oh, give me a prayer.
According to Newton's second law, the chair with the greater mass experiences acceleration at a lesser rate than the chair with lesser mass given the same force. The displacements of the two chairs in 5 seconds demonstrates different accelerations. Now, let's look at another example of Newton's second law.
This example shows how different forces will cause different accelerations of objects of the same mass. The bullet that was thrown by me went a lesser distance than the bullet that was shot by the gun. This was because the gun provided a greater force than I could match. Let's talk about Newton's third law.
Newton's third law states, if two objects interact, the magnitude of the force exerted on object 1 by object 2 is equal to the magnitude of the force simultaneously exerted on object 2 by object 1. And these two forces are opposite in direction.
In more simpler terms, every action has an equal and opposite reaction. Let's look at an example of Newton's third law.
When the two balls bounce on top of each other, their action forces cause reaction forces, making them bounce in the opposite direction. Let's take a look at another example of Newton's third law.
He was a boy, she was a girl. Can I make it any more obvious? He was a...
As you saw, when James pushed backwards on the ground, a reaction force propelled him forward. These are just some of the examples of how Newton's law can apply to everyday things. Physics!